Okay, welcome back to the second video for section 3.2, and at this video we're going to be taking a look at dealing with integrating products of powers of sine x and cosine x. And there's really two cases when we have sine and cosine. The first case is when we have an integral of sine and cosine and we have powers. So the power on sine is m and the power on cosine is n. And those powers, if you will, one of them is odd, or they could both be odd, so it doesn't really matter. But what we want to do in this case, whichever one is odd, we want to peel off one of those powers. If they're both odd, then we could pick either one, but so we peel off one power of sine or cosine, whichever has the odd power. And then we're going to do it much like we did in the last problem. So if you look at example 2, which one, sine or cosine, has the odd power? Well, it's definitely the cosine, right? So when we do that, we're going to go ahead and rewrite this. So this is going to be the integral of sine of x to the 6th power times the cosine of x to the 2nd power, and then we're going to peel an extra one of those off, so it's cosine x dx. And we can go ahead then and choose our U substitution. Since we have this extra cosine, that means we want to let U be the opposite of that, like we did in the last example. So U would be sine x, meaning du is going to give us that cosine x dx. Meaning dx is going to give you du over cosine x. So again, essentially this is our du right here, right? That extra power of cosine along with the dx, that's going to be our du that we found. And then since du involves cosine, everything else needs to be in terms of sine because that's what we're going to let u be. So this cosine squared x is a problem, but remember, we just use our trig identity. Our trig identity says that cosine squared x is going to be 1 minus sine squared x. So we're going to go ahead and rewrite this one more time before we make our U substitution. We can say this is the integral of sine of x to the 6th power times 1 minus sine squared x. And then we have cosine of x dx. And now we're ready to make our U substitution. So instead of sine of x to the 6th, that's going to be u to the 6th. And then we have 1 minus u squared. And then we have cosine of x times du over cosine x. And of course, our cosine x's are going to cancel. And so we got this nice integral to work with. And we can go ahead and distribute in the u to the 6th power. So this becomes the integral of u to the 6th minus u to the 8th du. And we take the antiderivative and we get 1/7 u to the 7th minus 1/9 u to the 9th plus c. And then, of course, we can back substitute, and we get 1/7. We have sine of x to the 7th power minus 1/9 sine of x to the 9th power plus c. And that is how we do example 2. We do have one more example to look at in this video. Again, the one we just did, that's case 1. That's when we have at least one of those powers of sine and cosine is odd. But what happens when they're both even? Because that's going to be the other scenario. That's case 2. If they're both even, if both powers are even, then we're going to use some trig identities to help us lower the powers on sine or cosine. So you can see some here in the notes that are going to be helpful to us. We have these here, which are going to be most of the time what we're going to use, but there's also this double angle identity that you can use as well. I generally use these half angle ones. So if you look at example 3, you can see we have the integral of sine of x to the fourth power dx. So if you look at example 3, you can see that we have the integral of sine of x to the fourth power dx. And we have an even power of sine. So this is where we're going to go ahead and use our trig identity. The first thing we want to do, though, is we want to go ahead and write this instead of sine of x to the fourth power, we want to write it as squared, because all these identities involve, like especially the ones in the box here, they involve sine squared. So we know, of course, that we can rewrite this as sine squared. We did that previously in an example in this section. And then we have the identity at our disposal. This is the same as the integral of what sine squared is equal to. That's this second identity over here in the box. And so this is 1/2 times 1 minus cosine 2x dx. That's squared. That quantity is squared. And so this is where some algebra comes in. We need to square everything inside those parentheses. So we have the integral of, first of all, 1/2 squared is going to be 1/4. That's because we have 1/2 times 1/2. And then when we multiply out this 1 minus cosine 2x times 1 minus cosine 2x, we have to square that. And you can go ahead and do that on the side if you want. 1 minus cosine 2x times 1 minus cosine 2x, right? That's what we get when we square 1 minus cosine 2x. So when you multiply all that out, of course, you're going to get 1 minus 2 times the cosine of 2x plus cosine squared of 2x. So taking a look at where we're at now, you can see that we have still an even power on cosine. So we're going to have to use these identities one more time. This time we're going to use the cosine one. And so we know that, just kind of writing over here on the side, we know that cosine squared x is equal to, if we distribute that 1/2, it's equal to 1/2 plus 1/2 times cosine 2x. But we don't have cosine squared of x, we have cosine squared of 2x. So that means when we have cosine squared of 2x, that means wherever there's an x, we're going to put a 2x. So we're going to have actually 1/2 plus 1/2 of now the cosine of 4x. Cosine of 4x instead of 2x. And so going ahead and putting those in, that means this integral, let's go ahead and pull the 1/4 out. We have the integral of 1 minus 2 cosine of 2x. And then in place of this cosine squared 2x, we're going to use this stuff over here. So we're going to have plus 1/2 plus 1/2 cosine of 4x dx. Now we're almost ready to integrate. We'll just combine those two constant terms. And so we have the integral, when we have 1/2 plus 1/2, that's going to give us 3/2. We have minus 2 times the cosine of 2x, and then plus 1/2 times the cosine of 4x. And now we're ready to integrate. The only thing is we do have a couple of U substitutions here, because we have a 2x inside of cosine and we have a 4x inside of cosine. But we don't need to fully write out that substitution. If you feel more comfortable doing that, you can. I'm going to do a mental U substitution. Remember, because there's a 2x here, that means we're going to have a factor of 1/2. And because there's a 4x here, we're going to have a factor of 1/4. If you just kind of do that substitution in your head. And so what we have is we have 3/2 x. And then we have -2 times a factor of 1/2. And the antiderivative of cosine is sine of 2x. Again, that 1/2 is from our mental U substitution. And then we have plus 1/2 times a factor of 1/4 times the sine of 4x. And again, that 1/4 comes from our mental U substitution, and then we have plus c. And so now we can just sort of clean everything up. We'll distribute the 1/4 back into each of these terms. Before I do distribute, let's clean up the inside here. So when we have -2 times 1/2, the 2's will divide out, and we'll remember that 1/2 times 1/4 is 1/8. So our final answer here, actually let's go ahead and write that out. So these two are going to combine and make 1/8, right? So our final answer, when we multiply 1/4 times 3/2x, we get 3/8 x. Then we're going to take 1/4 times this minus sine 2x, so that's going to be minus 1/4 times the sine of 2x. And then we have 1/4 times this 1/8, which is going to make 1/32. So we have 1/32 times the sine of 4x, and then plus c. And that will do it. That's going to conclude our video. When we come back, we'll have one more video. We're going to take a look at how we go ahead and integrate products of powers of tangent and secant. So see you in the next video. Thank you.